Hey everybody, I'm going to make a, quick video about some challenging code here. So let me first show you what it's doing, and then we talk about how I did it. So I'm starting with the ball here. When I click, the ball is going to travel at a speed towards that click point. Whenever I click somewhere else, it's going to follow that path. So what you'll notice here is like the ball is just traveling in a straight line towards wherever I clicked it, towards wherever I clicked. It's not jumping there immediately. I had to make it kind of move along a certain path at a certain speed. Let me show you. I can change some other things. I have my speed set in here. I could also change this value. Go a little bit faster. You notice it will fly past wherever my cursor is. It's just going to head towards that as like a starting point. So let's see what's going on here. So we had to do a little bit of fancy math in here. Basically, what I need to do is whenever I click, I need to calculate the difference between the location that I clicked and the location of where the ball is originally. Let's see it come back. So first things first, I need to figure out like what is the difference in x and y values between the ball's current location and where I'm trying to get it to go to, and that's going to really determine like that's my slope. What path does it need to head towards? Okay, so what I'm going to try and do in here, but if I just did that, if I just calculated the difference between like I have my x value here and my y value here. I click over here, calculate the x and y for my wherever I click. If I just move by that amount, it's going to immediately like teleport to my click spot. That's not really what I wanted to do. So I'm going to use like kind of a fixed speed. It's going to move at a certain speed as it travels. And I'm going to use, there's two basic ideas I'm going to use. Just some basic math stuff. I'm going to use a little bit of Pythagorean theorem and really just using a slope. So what I'm going to do in here, and I'm going to obviously share this code with a video, you've seen it already. I try to explain all the math that I did in here. It seems like a lot, but it's really not that complicated of math, but like applying it is a little bit kind of, seems like I think a lot more than it is. It's really not that bad. We just basically calculate the difference between the x and the y's like I talked about. From that, we're going to get the slope. And that's just kind of like what should be the ratio between how much do we want to move. If we move like 5 and y, how much should we move in x in order to actually like get where we want to go? So like if we move like 5, we should be able to know like if we move 5 in x, how far should we move in y? And that's really what the slope is going to tell us. And then what we're going to do down here is we are going to do, okay, so we can think about this, and maybe I'll make a separate video later. We can think about like the amount dx is like how much we actually want to move. Each step we can think about like we're going to move towards our location in like steps. Like how much should we move in x at each step, and how much should we move in y at each step? We can think about this as two legs of a right triangle, where the hypotenuse is the actual amount of speed, because that's going to kind of constrain how much we're going to move in x and y. You know, it's going to be kind of constrained by whatever our speed is. You can just, again, picture a right triangle. If the speed is larger, the triangle is bigger, and dx and dy will be larger. So that's kind of constraining the size of what dx and dy can be. So that's one constraint that we have on it. The other constraint is that we know that the relationship, how much we move in y and how much we should move in x, like those are fixed by the slope. And that's what I'm saying here. dy divided by dx is going to be equal to the slope. And so we really have two equations here, where we know what speed squared is. We can calculate the slope. We already know what it is. And so we can just do a little bit of like rearranging here. I'm going to take this equation, the Pythagorean theorem, and I'm going to substitute in, wherever I see dy, I'm going to substitute in this value. And that's we get this long equation here. The speed squared is equal to dx squared, again, Pythagorean theorem. But instead of y squared, I'm going to have this thing squared. Which, if we expand it out a little bit, not really expanding, but yeah, I guess it's still expanding, we're going to get dx squared times slope squared times dx squared. I see dx here in both spots in this part of the equation, so I can factor out a dx. And that's where I get dx squared times, this thing turns into 1, plus slope squared. Do a little bit of rearranging, and then so that's what I get here, just kind of restating that. And then, if I do just a little bit of rearranging, I divide both sides by 1 divided by slope squared, 1 plus slope squared, I end up with this equation. Finally, if I want to find what dx is, I'm going to take the square root of this thing, and that'll get me dx. If I have dx, then I can find dy by just multiplying the slope times dx, like same thing we had up here. And then from that, this is like how much we're going to move in the y, how much we're going to move in the x, and that's what we're actually going to move by. So we look down here, like I'm just gonna do the exact same. I'm gonna put this same exact thing into a little bit of code. Speed times speed instead of the square root thing or square thing. And then I have to do a little bit of messing around just because it's the difference in x, because it's like we're squaring the values. Sometimes if it's like a negative x value, it'll kind of mess up some of our code. So I just kind of did a little fix here. And then all I'm doing is like I'm just running this calculation whenever I click. Whenever I click, figure out, you can think of this as like whenever I click, figure out what dx and dy should be based on location. We'll have a location of the mouse. Okay. And then inside of my code, I'm just saying, hey, constantly move it. Whatever dx and dy are, move at that value. Move like at that, by that value each step. And initially, those values are 0, but they're going to get updated as soon as I click. All right, so there's a lot that kind of goes into this. I have different videos, I think, that go into more depth, but more complicated code. This is a good example of like some not too advanced of math. There's no calculus going on here. It's just some basic geometry, but a little bit kind of some fancy stuff, fancy application of it. All right, I'm gonna stop it there.